Alright, now we're going to take some examples from 2.4. Obviously these problems won't be allowed to be extra credit, so please make sure you don't do these. Now what I want to do is I want to take the derivative of g to the x. We're trying to show that we know how to use the chain rule. And I always rewrite it with a fractional exponent and get rid of the radicals. So now to take the derivative of this, I'm going to ignore the inside. I bring the exponent to the front, and then minus 1 makes that a negative 1/2 times the derivative of what's inside. So now I need to simplify. The 2's go away. I have a negative 1, and I can rewrite it as 3 minus the square root, or minus 1 over the square root of 3 minus negative 2x. Now when you look at number 2, and this happens to equal y, you might want to do the quotient rule, but let's make it easier first. Let's just bring it up and change the exponent to a negative 2. Now I can take the derivative pretty easily. This is a constant. I leave it alone. I bring a negative 2 in front. T plus 2, subtract 1, times the derivative of what's inside. The derivative of t is 1. So now what I end up with is 8 divided by t plus 2, and I raise that to the third power. This next example, what we're going to do is rewrite it so that you can see how the derivative is going to be taken. So now when I take the derivative, it's constants alone, I bring the 2 in front, I keep this the same, and this would be 2 minus 1, so there's a 1, times the derivative of what's inside. Well, what's the derivative of cosine? It's negative sine, whatever my argument is. Now this argument isn't just t, so I take the derivative of this as well, which gives me a pi. Now I can do a bunch of simplifying. I have 10 pi, I'm going to bring the negative in front, cosine pi t times sine pi t. And I've now found the derivative using the chain rule. All right, an example, in number 58, they want us to evaluate the derivative at this point. So I have to take the derivative, which is going to be the quotient rule. Low d high minus high d low over the square of what's below. Now, because they want us to evaluate the point, we could just plug it in, but I might want to do some simplifying first. So I have 2x minus 3. Keep in mind, it's minus this whole thing. So minus 2x minus 2 all over 2x minus 3 squared. Now I end up with the 2x's going away, and I end up with minus 5 over 2x minus 3 squared. Now it's asking me to evaluate it at the point 2, 3. So I'm going to plug in 2, and what I get is negative 5 over 2 times 2, which is 4, minus 3, which is 1, squared, which is 1. So there's my answer. Right, the next problem is, what we need to find is the equation of a tangent line at this point. So to find tangent lines, we take derivatives. And the derivative of tangent squared, you have to be careful. This is tangent x, and we're squaring it. So what I want to do is then take the derivative, and it's going to be 2 tan x minus 1 times the derivative of what's inside, which is secant squared x, times the derivative of x, which is 1. So this is what I've got for my derivative. Now I'm going to plug in pi over 4 and times secant pi over 4, and I'm going to square it. Now the tangent of pi over 4 is 1. Remember, it is in the first quadrant, and it's 1, 1, square root of 2, so 2 times 1. Now this is a secant. Secant is going to be the reciprocal of cosine. So we're looking at square root of 2 over 1, and then square it. Now we have 2 times 2, which is 2, times 2, so I end up with the slope being 4. Now what I need to do is find the equation of the tangent line. So there is my slope. So I take my point, y minus 1 equals 4x minus pi over 4. And that is going to give me the equation of my tangent line. Now they may want us to simplify, so what I'm going to do is multiply it through. Now there's the equation of my tangent line. All right, let's look at this one down here. We want to find out which graph is the original function and which graph is the derivative. Now keep in mind, when we take a derivative, we lower the degree. So my guess is going to be that this is the function and this is the derivative. So one of the ways to look is see where the horizontal tangents are. That means my derivative should have 0 there, which if I follow it down, that is the 0 of this function. If I take here and find the tangent line, it should correspond to that being the 0 of the function. So what I'm going to, and let's see, this is increasing to here, which means these are positive x's. And then it's a decreasing slope. So from here to here is a negative slope. And then it's increasing again, so it's a positive slope. We're going to take this and we're going to actually find the first derivative. It's 2 times 3x squared minus 1 squared times the derivative of what's inside. So I end up with 12x, x squared minus 1 squared. Now I can expand this. This is x to the 4th. Minus 2x squared plus 1. Distribute this through, and now I get an easier function that I can take the next derivative from. I could have done the product rule and chain rule, but why? Well, we can make it a little simpler. So now the second derivative is going to be 60x to the 4th minus 72x squared plus 12. 12 goes into all of them, so I'm going to factor it out. 5x to the 4th minus 6x squared plus 1. Now let's see if we can factor this out some more. I can have x squared, 5, 1, 1, minus, and I end up getting that middle term. So here is my second derivative, all factored out.